So an electron is accelerated through a uniform field of this strength, right? What energy in kilo electron volts will the electron have? Okay. So we draw our plates, the plus and the minus, right? That's what a uniform field means. This field is produced by two plates. And they're telling us that we have an electron, right? So an electron is accelerated through 0.4 meters. So let's just say that this entire distance is 0.4 meters. It doesn't have to be, right? But it has to be at least 0.4. So let's just say the electron starts from one plate and ends up at the other plate, right? But the electron has to be here. So see, this is something we need to think ourselves, so to speak, because it has to be repelled. The electron has to be repelled, right? So there's no point for me to place the electron on this side because nothing will happen. The electron will bang its head on that plate, not going anywhere, right? If the electron is here, it is attracted to the plus or repelled by the minus. So this is something that is not specified in a problem like this. They're not going to tell you the electron has to be on the positive plate or on the negative plate. But we know enough stuff by now, attraction and repulsion, right, to understand that the electron has to be here. Okay? So now we do what they are not telling us explicitly to do, but I said earlier, we should do this, right? So we should call this potential here V equal to 0. And that allows us to call this potential here V. We don't know it right now, but we can find it because we know the distance and we know the electric field, right? So we should always do this. The negative one, we should call it 0. And really, it's the formula that relates the potential difference with the electric field. Once again, everything stays put. We don't have to worry about anything. Delta V is equal to ED again. And again, we have everything we need. So 2 times 10 to the 6th, right? Multiplied by 0.4. So 800,000, right? 8 times 10 to the 5th, yeah. All right. So this is going to be 8 times 10 to the 5th volts. This is going to be 8 times 10 to the 5th volts, all right? 8.00, I suppose, if we want to do it nicely. So this is the potential difference. But now I know that, okay, if I call that 0, I know that this is actually 8 times 10 to the 5th volts. You see, it makes things a little easier to handle. All right. And now it's a conservation of energy thing, and it's very nice to write it. All right, so what energy does the electron have at the beginning? If the electron starts from rest, let's say, interestingly enough, both the potential and the kinetic are 0. Which sounds a little strange if you think about it. 0 energy? What's going to happen here? It is 0 energy because The kinetic energy is zero because let's say the electron is at rest. They're not saying anything, but they ask what energy acquires, the electron acquires. Well, let's say it had zero at the beginning, right? Or maybe I should say the other way around, because V is zero, right? K is zero, right? So if it's not zero, it's not zero, but let's say it is. But this other one is zero because we have the formula QV. And V is zero. I chose V to be zero. So here, the potential energy is zero. But again, it's like the MGH being zero at the ground level. It's because I chose that level to be zero. So if we think of something, how is that possible? Think, right? You launch an object or those problems with roller coasters, I'm choosing the zero at the lowest point. So it is zero. Okay, that means the energy on this side, the total energy here, must be zero. It feels a little strange because when the electron gets here, right, its energy must be zero, right? Doesn't sound a little strange, right? If you think about it, so this is the initial state, right? We start our problem here. And this is final. We cannot switch these two because the electron would never make it on the other side if it's the other way around. But so the electron moves, right? It's repelled by minus, it gets there. So now, because of conservation of energy, the electron has zero energy. How is that possible? We don't need to think too much about that, really. We just follow the formulas. So K is going to be 1/2 mv squared. No problem. Actually, there might be a problem. If the speed is too high, it might be relativistic, but I don't know. Let's not worry about that. So K is 1/2 mv squared. But that means U has to be negative, right? U has to be negative because otherwise this will never happen. How can I add two quantities and get zero? So the question marks means, wait a minute, I hope everything is okay, right? I hope everything is okay. This is negative because it is the charge of the electron, Q, right? Multiplied by the voltage, by the potential. It is negative, and that's a relief. Everything makes sense. It is negative, and that's a good thing. It feels strange to say the initial energy is zero. You know that the final energy must be zero. But on the other hand, final is kinetic plus potential. I say, well, I'm adding two things. I want them to be zero. I know math, plus and minus gives me zero. That's not the problem. But what's going to be negative here? QV. Q is the charge of the particle, an electron in this case, and it is negative. So everything is good because now I can find the speed. I don't know if numbers will cooperate. I hope this speed is not too large, but let's not worry about that. If it's too large, that means we'd have to use relativistic effects, which obviously we are not ready for it. But in principle, we can now find the speed of the electron. Appreciate the formula, kinetic plus potential. And mathematically, it makes sense. I would have been worried if I had plus is equal to 0, right? Then I would have said, well, I did something wrong. The problem doesn't make sense. But mathematically, right, this problem makes sense. And I'm missing here the negative 19 for the charge. Sorry about that, it's not positive, right? Typo. So we can find the speed of the electron. And whatever we get is good. So let's get the number. I mean, maybe I should say whatever we get, that's what it is. I cannot say it's good, because if it's too high, that would not be good. But there's nothing for us to do right now. So 1/2 mv squared is equal to 1.28 times 10 to the negative 13. This is what I got when I plug in 1.6. 1.6 times 10 to the negative 19 times 8 times 10 to the 5th. Everything I think is good so far. So we can solve for V. All right, so the mass of the electron is a well-known quantity. We don't have to memorize it, but what I'm trying to say, we know it. It's 9.11 times 10 to the 31, to the negative 31. So 2 multiplied by this and divided by this, so 10 to the negative 31. So I'm plugging in the quantities. So we know exactly what numbers we are doing here, right? 2 times 1.28 10 to the negative 13 and divide by the mass. So 9.11 10 to the negative 31, it is the mass of the electron, right? So it's as long as something is specified, like electron in this case, it's fair game, right? Even if we don't know the mass, we can look it up. And this is exactly what I was afraid. Horrible. Absolutely horrible. 5.3 times 10 to the 8. It cannot happen. I was afraid of that. It's exceeding the speed of light. So, well, for the purpose of this example, it is what it is. I had a feeling it would happen. Big problem. But in terms of approaching a problem like this, it's okay. So not good, because it exceeds the speed of light. Well, it's something that will come up later in the course. Obviously, they didn't ask us to find the speed. This is when you do things you are not asked to do, right? But anyway, so the value, completely ignore it. It doesn't make sense. We are not happy with the actual value. But this is how we solve a problem. So it's just a problem of numbers, right? It's just a problem of numbers. If the numbers were chosen correctly, we'd have been happy. But this is how we do a problem like this. So now in principle, if we're a little more advanced, we'd say, well, this cannot happen. That tells you that we have to use special relativity, something that is to be studied a little later. So this approach will not work to find the speed of the electron. But in terms of the approach, this is the correct ones. And I'm glad we had this discussion about total energy being 0, right? The total energy being 0. right? And the energy that the electron acquires, so this is this electron volt thing, right? So of course it acquires, so the energy acquired, right? So this is the kinetic energy, right? Kinetic energy acquired. Look how easy it is to read it. We say, well, it acquires 8 times 10 to the 5th electron volts. Look how nice. Electron, all right? The formula is U is equal to QV. But if you make Q the electron, you make it EV, and the unit of the energy, in this case, you can say is the electron volt. It is a unit that is used in spectroscopy and other things in chemistry. So it is the energy acquired by an electron under a potential difference of 1 volt. It's good to know, and it's very convenient, because look, we wrote this 8 times 10 to the 5th here right away simply by reading this value. We didn't do any math here. So, well, I have an electron, and it goes from 0 to 8.10 to the 5th volts. Well, it acquires 8.10 to the 5th electron volts. So it is a unit of energy, a convenient one. So let's overlook, unfortunately, but it's still a good lesson. Let's overlook the fact that the speed here is higher than the speed of light, right? There's nothing we can do with these numbers. It can be avoided. Now we say, well, we'll have to take a different approach, but we are not ready for that approach. So let's overlook that for a moment. But the solution here that we should not overlook, because this is how we solve problems. And it feels a little strange at the beginning because we have this zero energy. And it has zero energy, and then it's moving and say, how can I end up with zero energy in the end? Well, one is positive, the kinetic energy has to be positive, which means the potential energy has to be negative, but we don't have to force it to be negative, because that's what my formula tells me. U equals QV, and if Q is negative, guess what? The potential energy is negative.